Okay, we are going to do some review for the test that you need to take this week. So I'm going to show you a handful of problems, all of which are incredibly similar to the ones that are on the test. So let's get started. This is the first kind of problem you're going to need to solve. So it's going to be 6 multiple choice questions still and an extended response. This is very similar to a multiple choice question that you will see. We need to solve it. So we're trying to get x by itself. But if you notice right away, we have a problem because both of our x's here are under the cube root sign. So there's no numbers on the outside, so I don't need to worry about doing anything with those. All I need to do is cube both sides, and that's going to get rid of the cube root sign. So I'm left with 3x minus 7 on this side and 5x plus 17. Okay, so really now we just have a multi-step equation that I need to solve. So I am going to get all my x's on one side. It doesn't actually matter what side you get them on. So I'm going to move my 3x. I like to keep my x's positive. There's no good reason for it. You could have done a different first step. This leaves me with negative 7. And on this side, I have 2x plus 17. So I subtracted 3x because it was already positive, and what I do to one side, I do to the other. And I already have a like term over here, so I lined them up. All right, now I have a two-step equation, and now I'm going to move this 17. Now, a lot of people want to move this negative 7. Don't do that because we're trying to get x alone. That means we need to move things away from x. So I'm going to subtract 17 on both sides, and I have 2x equals, and I subtract these, and I get negative 24. Okay, and then I just have one step left. I'm going to divide both sides by 2. Gets rid of my 2 over here. I'm left with just x, or 1x, and over here I have negative 12. Okay, I don't need to check this in Desmos because it is an odd root. You do need to check the other kind in Desmos. Anytime you have a square root, no matter what, or a fourth root or a sixth root or eighth root, if you have an even root, you have to check it in Desmos. But this is a cube root. I don't need to check it in Desmos. So that is my solution. That is my only solution. In this case, I just have 1. So that's how you do that first kind of problem. All right, let's look at the next kind of problem. There are a couple of these on here. You are going to rewrite it with radicals. So remember, this is your base. So here's my radical. My base goes under here. The bottom here is your root. So 2. And then your numerator, or the top of your fraction over here, would look like that. So this one would actually be simplified to look more like the square root of 7. I don't think the one on that test is that tricky. I think they're more like these two. So we're going to keep, here's our radical sign, and here's my base. Your denominator becomes the nth root you're taking, so the fourth root. And this numerator up here becomes the exponent on your base, so 3. So you just want to keep track of where each part goes. The base goes under the radical, the denominator goes in where the nth root was, and your numerator becomes the exponent. Okay, so let's do this one. We have a radical, and there would be a 5. 7, that's my root. So 7th root of 5, and then 5 is being squared. Okay, so you're definitely going to be one of those on the test. Okay, now we have another solving problem. So this one, we've got to solve. And again, we're trying to get x by itself. That's what we're always doing when we're solving. And this time there's no radical sign, but what we do have right here is an x to a 4th power. So we're going to have to deal with that towards the end. Okay, so the first thing we're going to do is just move this 80. We're going to add it to both sides, because that's going to give us just x to the 4th over here. What do I do to one side? Do the other. And then I've got 140 over here. So I'm going to move this down and rewrite it down here so you can see what step I'm doing. I need to get rid of that to the fourth power. I need to get rid of this exponent of 4. And to undo that, we're going to take the fourth root of both sides. We're going to take the fourth root of both sides. This is now where you're going to need Desmos. So this gives us x by itself. Now, if you notice, we have a fourth root. So that means our answer is going to be a plus version of it and a minus version of it. Just like when we had square roots, we had a plus version and a minus version. Okay, so let's go to Desmos. So type this in over here. We're going to go to functions, miscellaneous, and here's your nth root with the radical sign. I'm going to type in 4, and under the radical goes 140. So my answer is a plus and a minus, so 2 different answers here. And I'm going to round to the hundredths. So 3.44. So remember, when we're rounding to the hundredths, this is the hundredths right here, but this 9 to the next of it, to the right of it, 5 or above, give it a shove. So that's why it became 3.44. Okay. So definitely going to be one of those kind of problems on the test. Okay. Here is a problem that was similar to the first one that we did, except this one, there is a number on the outside, and that's going to kind of change our answer. So you don't have to do the full problem. You just have to do the first 2 steps, and that's how it is in the multiple choice. It just asks you what step comes next after, I think, the first step. So our first step here, we can't move this 4. It doesn't make sense to subtract it or divide it on both sides. That makes no sense, because that would just give us a 4 on this side as a denominator. When we have radicals on different sides of the equal sign, we are going to undo the root. So in this case, it's a square root. So I'm going to square both sides. Now, on this side, that just gives me x minus 2. Nothing changes. But on this side, this is where people get caught up. So this becomes 4 squared. And then the x plus 1 is inside the parentheses. So you're going to have to do one more step after this, and that's going to be to take to square the 4, and you get 16, and then x plus 1, and then over here is x minus 2 still. So a couple things I want you to notice. This 4 also got squared. Okay. Also notice that this x plus 1 was being grouped by the radical. It had to keep being grouped separate from this number over here. Notice also that when we took the square root of this, nothing under the radical on this side changed. X minus 2 stayed the same. All right, so you don't even need to finish that problem. You just need to know that step. This is really important. So that's why I'm kind of making a big deal about it. Okay, that leads us to our last kind of problem. And you're actually going to see 3 of these. So I'm going to show you a kind of a couple different versions of them and what you have to do with them. So the first one is you just have to know each step. Like, what would you do first? What would you do second? What would you do third? In fact, you're going to have to be able to describe that in words for the extended response. This is a multiple choice, and what you'll see is that there's an error. So for error analysis, there's a couple ways to do that. You can look at the problem and kind of walk through and follow their work, or you can work the problem out and then compare it to see what they did. Either way, I want to make sure you know the actual steps. So we always want to get the radical alone. We're going to have to move this 15 first. So I'm going to move that over here. Okay, so I'm left with, I still have 5 radical x plus 1. And over here, when I add them, I have 60. Okay, my radical is still not alone yet, so I can't square both sides or cube both sides or whatever it is I need to do. I need to move this 5. So I'm going to divide both sides by 5. So I have the square root of x plus 1 and 60 divided by 5, which I'm pretty sure is 12. Okay, so now I'm at the point where this radical sign is by itself on the left or on one side the equal sign. So I'm going to get rid of that radical. And in this case, I'm going to square both sides. because that's how you undo a square root. So I'm going to square this, and I'm going to square this. Okay, so that gives me x plus 1, and 12 squared is 144. Okay, so I still have to solve for x, so minus 1, and my answer is 143. Now, because this has a radical that is an even root, I have to put this into Desmos. I have to check it in Desmos. You have to check the even roots in Desmos. So I'm going to open up Desmos over here. Hey, come back. Let's move that over here. All right. So I'm going to sub it in. So here's what the original problem looked like. X plus 1. Make sure you get out of that radical sign, minus 15. And then on this side, we know it has to equal 45. But we want this line and this line to equal each other. Well, this is already 45, so you know that. This one, instead of this x, I'm going to sub in 143. And you notice it gave me the right answer. So 45 equals 45. That means that 143 is a solution. If it didn't work, then you would say it's not a solution. And in the past, we've gone kind of more in depth to that vocabulary, but for our purposes, we're just going to keep it at that. Okay, so this is another problem, very similar to that last one, but the answer is being given to me. The answer that they got, x equals 52, is correct when you actually do the math. I promise it's correct. But that doesn't necessarily mean it's a solution, because you notice I've got a square root here. So I'm going to go back to Desmos. I'm going to check this. This is where you need to check it. You don't need to do all the work over again. You need to check it. So my original equation is the square root of 2x minus 4. And on this side, I have negative 10. So I want this side and this side to equal each other. So I got 52 by solving it, but that doesn't necessarily mean that it makes the equation true. So I'm going to sub in the 52 here. And notice what I got. I got positive 10. Positive 10 and negative 10 are not equal to each other. I know they're very similar, but they are not equal to each other. So what does that mean? That means that although you could get the answer 52 by doing it algebraically, 52 is not a solution. It is not a solution because it did not make the equation true when I subbed it in. That's really important.